we just kind of look at this from a pictorial standpoint here for a minute, all right, graph the V however it happens to be. It can be shifted away from the origin, up or down, left or right. Doesn't make any difference. All right, let's say right there's your V. All right, now that V would be an absolute value. There would be some absolute value in there, okay? Could just be about anything. I'm not even, it's absolute value of something, okay? And for it to be an equation, okay, it will be set equal to some number, okay? Maybe, say, 6. Now, if you conceptually understand what this is meaning, then when you look at it from a graphical standpoint, then it will start to make sense. Okay, so this portion of that equal equation right there, that portion right there is the V. All right, that's the shape. You're going to get a V from whatever's on this side of the equation. All right, and it's asking you, when we say is equal to 6, basically it's asking you, well, where is the absolute value equation equal to 6? All right, so the equals 6 part, all right, well, 1, 2, 3, 4, 5, 6, let's say that's 6 right there. Where is the absolute value equation equal to 6? So there's the horizontal line representing the 6, horizontal line at y equals 6. All right, so what value, what x value does that cross at? What x value does it cross at over here? This would be a negative number. Who knows? Maybe -2. This would be some positive number, maybe 5. So then your two equations, or your two answers, would be x equals -2, x equals 5. That's why you get two answers when you solve an absolute value equation. It's asking you, well, where is the V crossing whatever that happens to be in the right hand side, whatever that number is. And since it's a V, unless that this value right here happens to be at that vertex, it's going to cross in two places. So that's why you always have two answers. And most of the time, especially at the high school level, we give them these absolute value equations, all right, and they just totally ignore the absolute value bars and solve it like regular, okay? Well, then what's going to happen? You're going to get one of those two answers. If you totally ignore the fact that there's absolute values in this equation, you will get one of the two answers. You just won't find the second one. All right? So we'll premise there on where we're going, why we're going from a pictorial standpoint. All right? Now, the way we're going to solve these, all right, our method or rule, let's just call it a rule. Our rule that we're going to use to solve our absolute value equation is if we have the absolute value of something, all right, so the absolute value of u, and that is set equal to c, algebraically, from an algebraic standpoint, what we're going to do is we're going to break this into two separate equations so that we get both of these answers. The first one, I always do the exact equation that it is, and I take away the absolute value bars, so I set u equal to c. That's going to give me one of the two answers. All right, it will become an OR, automatically, guaranteed. And then I take the equation, and the only thing I do is I change the sign of whatever's on the right hand side. So like u equals a -c. All right, so change sign. I'm just going to say change the sign there. And then this then will give you your second answer. So like I said, if you take this equation and you solve that equation and you just kind of ignore the absolute value signs, you will get this answer. The answer you won't get is the second one, because you've got to take that equation, change the sign, and then solve it. Okay, no matter what that u is. The u could be something very, very simple. It could be just a plain x in there, or it could be 2x minus 3, 4x plus 5, could be just about anything on the inside. So that's kind of the rule that we're going to follow. Okay. Now, with that said, let's actually take a look at an example here. Let's suppose we had, say, absolute value of 2x minus 3 is equal to an 11. All right, the key here, remember, you've got to break it up into two different equations. So when I write the first equation, I write it exactly as I see it. I drop the absolute value bars. So I write 2x minus 3 equals 11. Okay, then I put the or in there because absolute value equations with an or in there, or with an absolute value with an equal sign, will always be or. I'm going to write this equation again. I'm going to change the sign on the 11. So 2x minus 3 is equal to a negative 11, and that's the part you got to memorize. Okay, change sign. All right, and then as long as you can break it up into two equations like that, all right, you should be pretty good. These are going to be relatively simple equations you can solve, two-step equations, maybe some distributive property, maybe x on both sides. All right, we'll go ahead and finish this one out. 2x is equal to, if I add 3 to both sides, then I'm going to get a 14. Here, dividing by 2, I'll get an x equals a 7. Okay, over here, if I add 3 to both sides, I'll have a 2x. Let's see, add 3 there is going to give me a negative 8. Divide both sides by 2, we'll have x equals a negative 4. Okay, now, for our ors, that's exactly how you can write your answer. With the word or in there, technically the or really needs to be in there. If they tell you to use a solution set, then it's just going to be those two numbers in your absolute value, or in your brackets. So like a negative 4 and a 7. And I do think my math lab does the solution set thing. Your graded homework does. All right, now the one thing that I have not addressed yet is you should always check for extraneous roots. Okay, because just because you worked all this out and you've got these two answers, there's no guarantee that when you put them back into the equation that they're going to make it true. All right, so you should do the check part. All right, we're going to check x equals negative 4. All right, so just plug it back in for x. So absolute value of a 2 times a negative 4 minus a 3. And then you're asking yourself, does that equal 11? Excuse me. At this point, if you don't put that question mark above the equal sign, then really technically you're not doing it mathematically correct. We're questioning, does this equal that? Inside those absolute value bars, a negative 8 minus a 3. Still, does that equal 11? Absolute value of a negative 11. Does that equal a positive 11? When we take the absolute value, we get a positive 11. Okay, so yes, it does. Check. So then that means x equals 4. Yes is definitely a solution because I checked that. Okay, we could do the exact same thing. I'll do it on this first one. I probably won't go through the check on more examples later on. We'll go ahead and check the x equals 7. Again, plug that in to that original equation. So 2 times 7 minus 3. Does that equal an 11? Well, that'd be a 14 minus 3. Absolute value bars around it. Does that equal 11? 14 minus 3 is going to be 11. Absolute value of a positive number is positive. So again, 11. Don't need the equal sign, or don't need the question mark on the last step because it's a true statement. So in both of these cases, yes, they both did happen to work. All right. If one of them does not work when you plug it back in, you have to throw it out. It would be referred to as an extraneous root. Okay, so that will happen probably more often than you would think. Okay, all right, so basically that's pretty much the equations. All right, now if we did it from a graphical standpoint just a minute ago, all right, then technically you could check all of these before you turn your paper in because you could put them in your graphing calculator and check. Okay, so I just wanted to show you how to do that, what it would look like. All right, if you wanted to check your answers on your graphing calculator, let's do a GC. All right, let's just take that same equation we just had. Absolute value 2x minus 3 is equal to 11. All right, what you're going to do is you're going to put the left-hand side of that equal sign into the y1 on your calculator, and then you're going to put the second part into y2. Okay, the y1, the y2, we've all kind of done that graphing a little bit and played with it. All right, then what's going to happen from that graphical standpoint that we just saw, all right, as opposed to pulling a calculator out and actually doing it, I'm just going to sketch what you're going to see. Okay, at about 1.5, the V, or the point of the V, is going to be right there. All right, and then let's go ahead and do this. Y1 I said was red, so if you use the graphing calculator that's in color, then you're going to see a V, and a V like this. All right, you're going to see the 11 in blue as a horizontal line. All right, and then where's the two answers going to be? Well, the answers are the points at which they cross, and over here we got a -4 and a 7, so this would be a -4 on the x-axis, and where they cross over here would be a 7 on the x-axis. So there's where we're getting the x equals -4 and the x equals 7, because it's the x value of the point at which they cross. The x value at the point at which they cross.